Science is fun. It helps you to learn.
And oh, what fun it would be.
Yo, check this out.
Fascinating, interesting, mysterious, wonderful. But this is only the beginning.
Okay, Beans, you all set to fire it up? Fire it up.
This is called latent fingerprints.
Fingerprints provide a positive means of personal identification and form an indisputable link in the chain of evidence.
It is our responsibility to identify stains that are made by the various body fluids.
Old-fashioned guesswork is replaced by certainty, saving hours in following useless clues.
Countdown to the scientists.
The facilities we have available for this purpose include the emission spectrograph, the mass spectrograph,
Fibers attached to the window casing. These pieces of evidence are preserved for laboratory examination.
Yo, check this out.
When physical evidence is found, it is immediately photographed.
These pieces of evidence are preserved for laboratory examination.
Yo, check this out.
Here are dual microscopes, being used to see if two bullets are of identical make.
It's weird science.
They may prove innocence as well as guilt.
Welcome to the Denver Police Crime Lab. I'm Greg LeBerge, director of the laboratory. This facility was developed with clean spaces, which are areas inside each crime lab unit that must remain free of any contamination. Masks, gloves, and lab coats are required inside many of these clean rooms, which is why we can't give you a closer look behind the scenes of the lab. Instead, we've produced this video to give you an intimate look at what goes into a forensic investigation. You'll learn about each unit of the crime lab and how their results can impact the outcome of criminal cases. Be sure to ask your tour guide any questions you might have, especially if you're interested in becoming a forensic scientist or a crime scene investigator someday. They are unique professions and a great way to serve the public and contribute to your community. We believe the Denver Police Crime Laboratory and our personnel are the best in the United States, if not the world, and we strive to make Denver a better place to live and work every single day. You can find more information about the Denver Police Department and all the important work they do by following them online. We hope you enjoy your time at the Crime Lab and come away with a better understanding of how forensic investigations really work.
The Firearms and Toolmark Unit conducts many different types of examinations. They do mechanical function checks on firearms to see if they're working properly. This includes test firing of firearms for bullet and cartridge case specimens for possible comparison with evidence. Gunpowder pattern testing, also known as proximity testing, to determine the distance a firearm was from a victim. Microscopic comparison of fired bullets and cartridge cases to determine if they were fired by a specific firearm. Microscopic comparison of tools, like screwdrivers, wire cutters, or punches, to tool marks or physical matches left at a crime scene. And restoration of obscured serial numbers on firearms and other objects using specialized acids. The Firearms and Toolmark Unit also utilizes the National Integrated Ballistic Information Network, or NIBIN, database entries and examinations. NIBIN captures digital images and 3D renderings of unique marks on fired cartridge cases recovered from crime scenes or test fired on our forensic firearms range. It compares these images to others in the NIBIN database to see if they match any previous shooting incidents. Any potential associations found using the database are confirmed via traditional microscopic comparisons. This is done using our Leica comparison microscope, which is the primary instrument used by a firearm and toolmark examiner. This microscope allows for the side-by-side comparison of evidence at up to 60 times magnification. The Firearms and Toolmark Unit maintains a large firearm reference collection, which serves an important role in training and research. It provides a reference for serial number appearance, composition and location, and is a source for replacement parts when they're needed to make damaged or disassembled evidence firearms operable. The final stop on our tour of the Firearms and Toolmark Unit is the Forensic Firearms Range. This 75-foot long space is used to safely test firearms when no bullet recovery is necessary. When a test bullet is needed, the bullet recovery tank is used. This specialized water tank allows for the collection of fired bullets that maintain their original, undamaged condition. The Forensic Imaging Unit consists of personnel trained in forensic imaging techniques and video analysis using scientific examination, comparison, and evaluation of evidence in legal matters. The Forensic Imaging Unit's primary function is retrieving video from crime scenes to capture still images of suspects, vehicles, and persons of interest for investigators. This unit also assists detectives with playback and review of acquired surveillance video. With video coming from many different sources, playback of proprietary video can be quite complex. The images cannot be distorted or appear altered in any way from their original appearance on the digital video recorder. A sophisticated video editing system is used to work on more complex cases. This software allows an analyst to enhance a video image and make it easier to view unique, identifying characteristics. Edited video will sometimes be released to the public in an attempt to locate suspects or persons of interest. The Forensic Imaging Unit is also responsible for securely archiving photographs of evidence from crime scenes, traffic investigations, and other crime lab units. These images are sent to a secure server, then retrieved as needed for detective case filings or trial. The unit photographs DPD personnel, as well as victims, suspects, and property items for use as evidence, and performs other specialized photography as needed by investigators. They help train other units to photograph evidence, and also train sexual assault nurse examiners throughout the city of Denver. Finally, the Forensic Imaging Unit helps assist in cold case investigations and prosecution. This is done by converting older, analog media like VHS tapes and audio cassettes to a cleaner, easier to navigate digital format. The main responsibility of the latent prints unit is to process evidence for the presence of latent prints, then compare them to known fingerprints and palm prints. One of our main tools to develop latent prints is the cyanoacrylate fuming chamber, also known as a superglue chamber. A small tray of superglue is heated until it becomes a vapor. Humidity is added to the chamber, causing the vapor to adhere to any latent print residue an individual may have left behind. A liquid dye stain is then applied to the items. The stain adheres to the cyanoacrylate residue, making any latent prints easier to view under a laser. The dye stain on these items is activated when put under the laser. Wearing color-filtered goggles, an examiner can visualize any possible latent prints that may not be visible to the naked eye. When we have latent prints to examine and compare to known prints, we have access to two searchable databases. One is a federal database that searches criminal, civil, and military print records. The other is a state database that searches criminal and civil print records. Both databases assist us in identifying latent prints by returning a list of possible matches based on the unique characteristics of each print. An examiner reviews this list to check for any potential matches. If an identification appears likely, the examiner then completes a manual comparison of the latent print to the known print from the database. While there are many tools to assist the latent prints unit in identifying print matches, this final manual comparison is always completed by an expertly trained latent print examiner. Almost 100 years ago, Professor Edmund Lockhart stated, "For the microscopic debris that covers our clothes and bodies are the mute witnesses, sure and faithful to all of our movements and all of our encounters." The Trace Evidence Unit is responsible for collecting and analyzing that microscopic debris to help establish the elements of a crime. Analysis can be performed on the smallest of items, a single hair found on a weapon used in an assault, glass discovered on the clothing of a burglary suspect, and even microscopic particles of paint found on the victim of a hit and run. To gather trace evidence from a piece of clothing, an analyst will first visually inspect the item. Then, they scrape it down to isolate any debris containing potential trace evidence and collect it for further, more extensive examination. Materials that are frequently recovered and examined include hairs, fibers, glass, paint, construction material, tape, cords, rope, wood, and plant material. The Trace Evidence Unit analyzes explosives and explosive residue. They are also responsible for the examination of materials associated with the discharge of a firearm. This is known as gunshot primer residue testing. This kind of test is performed on a scanning electron microscope, which can magnify items up to 300,000 times their normal size. That's enough to detect microscopic particles of explosive primer on a suspect's hands or clothing. A common tool used by analysts in this unit is the comparison microscope. A comparison microscope is essentially two compound microscopes tied together with an optical bridge so that fine details of known samples can be compared side by side with samples of potential evidence. Other microscopes utilized in the microscopy laboratory include a polarizing microscope, fluorescence microscope, and phase contrast microscope. The scientists in the Trace Evidence Unit also utilize modern chemical analysis instruments in their evaluations. An ion chromatograph, for example, is routinely used to identify chemical ions contained in debris from explosives investigations. The Forensic Biology and DNA Unit occupies the entire second floor of the Denver Police Crime Laboratory. The Forensic Biology Unit examines evidence recovered from crime scenes for potential biological matter. They identify biological fluids, then take swabs or cuttings from the evidence and process them for analysis. Cases that test positive in the Forensic Biology Unit go on to forensic DNA analysis. The goal of the DNA unit is to develop DNA profiles from items of evidence and compare them to known DNA profiles from crime investigations. Evidence is examined from many types of cases, including homicides, sexual assaults, robberies, aggravated assaults, kidnapping, and property crimes like burglaries and theft from a motor vehicle. Cold cases are also examined, including homicides and sexual assaults dating back to the 1960s. Work in the forensic biology unit begins with a visual examination of evidence for staining. Biologists take samples of potential stains to test for the presence of blood, semen, saliva, or cellular material. Hairs can also be tested if they contain roots suitable for DNA analysis. Stains not visible to the naked eye can be located with an alternative light source. Some body fluids fluoresce under this blue light, making it a useful tool for finding stains that aren't visible using natural light. Any biological evidence obtained is stored in a walk-in freezer until it's ready for DNA analysis. The DNA analysis process uses a variety of manual and cutting-edge robotic methods to analyze samples and develop DNA profiles. Every DNA sample goes through a 4-step process. The first is a DNA extraction, which is done to purify the DNA in a sample. After extraction, samples are passed through a secure chamber from the pre-amplification to the post-amplification laboratory. The next step is DNA quantitation, which determines how much DNA is present in each sample. That's followed by an amplification step, where the DNA is copied millions of times. Finally, the DNA is detected on an instrument called a genetic analyzer. This machine assembles the finished DNA profile, which analysts use to determine if biologic evidence from a crime scene matches the known DNA profile of a victim or suspect. DNA cases that are submitted without a known suspect can be searched in the Combined DNA Index System, or CODIS database. This is the largest DNA catalog in the world, with over 14 million profiles. CODIS is used by law enforcement agencies in the United States to help solve unsolved cases. The primary responsibility of the crime scene unit is to assist detectives with a response to and processing of approximately 5,000 crime scenes each year. Crime scenes include everything from burglaries, auto theft, and aggravated assaults, to more complex scenes like homicides, sex assaults, and officer-involved shootings. Processing crime scenes involves crime scene management, documentation including photography and video, and the identification, collection, and preservation of evidence. Depending on the type of crime scene, several different specialized processing techniques can be used. These include shooting reconstruction and bullet trajectory, bloodstain pattern analysis, DNA and trace evidence collection, and latent fingerprint processing. The crime scene unit utilizes a 35-foot mobile crime scene command center at major scenes to help facilitate staging and processing. In the forensic garage at the Denver Police Crime Lab, there are 3 separate vehicle processing bays. One of the bays features a hydraulic lift used to search for evidence on the underside of vehicles. Another bay is equipped with a cyanoacrylate or superglue fuming chamber. This allows investigators to fume an entire vehicle at once, then locate, recover, and submit latent fingerprints for analysis. A full complement of pneumatic tools is also available in the forensic garage. These are used to disassemble vehicles and recover evidence. In 2013, the crime scene unit began a change from sworn police officers to civilian personnel. Today, the entire unit is staffed by civilians. The Forensic Chemistry Unit handles over 5,000 narcotics cases per year, which requires the analysis of tens of thousands of items. The unit processes over 800 blood alcohol cases each year, used to determine if a DUI has been committed. The Forensic Chemistry Unit also performs an analysis for ignitable liquids in arson investigations to assist the Denver Police and Fire Departments. As part of its state-of-the-art laboratory, the Forensic Chemistry Unit has gas generators to produce all the gases used by its instruments. The generators produce hydrogen as a carrier gas and fuel gas, nitrogen as a carrier gas, and ultra-purified zero air used in flame ionization detectors and to purge water from some instrumentation. Here, vials of blood are being prepared for headspace analysis, used in suspected DUI cases. Alcohol in the blood samples is analyzed by heating the blood to force the volatile alcohol into the air at the top of the vial. To start the process, samples are placed into a heated headspace autosampler. This machine takes the vials and places them into an oven. When they reach the proper temperature, a sample is collected from the headspace and injected into an instrument called a gas chromatograph. The alcohol value of the blood sample can then be determined. A common instrument used to analyze controlled substances is the Fourier Transform Infrared Spectrophotometer. It takes approximately 30 seconds to perform this analysis, which produces a structural identification of relatively pure organic compounds. Controlled substances are verified using a series of color tests to indicate the possible presence of different narcotics. The orange color here indicates the sample contains an amphetamine-like compound, possibly methamphetamine. The next sample remains pink after testing, indicating it does not contain cocaine. And the third sample turns a dark blue color, which means there is a secondary amine present. The result of these three tests show the sample is likely methamphetamine. In addition to narcotics testing, the Forensic Chemistry Unit also analyzes for ignitable liquid in arson debris cases. The sample being prepared here will be heated in an oven along with a carbon tab. The small tab, which is placed on the lid of the testing container, will absorb any volatile compounds that are driven off the material inside. Those compounds are then extracted from the carbon tab using a solvent. They can be analyzed using an instrument called a gas chromatograph mass spectrometer, which is also used in controlled substance analysis. The Forensic Quality Assurance Unit provides administrative support to crime scene personnel, forensic scientists, and laboratory management. Quality assurance personnel are responsible for maintaining all documentation and demonstrating compliance with ISO standards and the quality program. Other responsibilities include processing laboratory requests, pagination, filing of case reports, ordering laboratory supplies, processing subpoenas, and providing case discovery for trial. The Denver Police Crime Laboratory is accredited under ISO 17025. This is an international standard that governs testing and calibration services. It requires extensive documentation and a quality system be in place to monitor all activities and forensic analysis completed within the laboratory. It took more than 7 years for the crime lab to achieve ISO 17025 accreditation for every unit. Forensic Biology DNA was the first unit to receive accreditation in 2005. They were followed by Forensic Chemistry and Trace Evidence in 2006. In 2009, the Firearms Toolmark and Latent Prints units completed accreditation, and in 2011, the Forensic Imaging and Crime Scene units received their accreditation, making the entire Denver Police Crime Laboratory ISO 17025 accredited.